Hello everyone, this is Ayush along with Saangya from IIT Mandi, and our problem statement for SIH 2024 would be identification of cryptographic algorithms using AI and ML techniques. So the question arises, why would you need these things? So as the need of the hour suggests, security demands a lot of things, and by predicting what sort of algorithms are these and classifying these, we could identify the possible vulnerabilities of a particular algorithm and which could further help make the security structure more robust. So how are we going to do this? So Soumya is going to continue with that.
So now we'll explain you the basic approach we have done in our presentation. So what we have done is we have used our autoencoders to create a small embeddings of the cryptographic text, and these embeddings we are passing into the random forest classifier, which is classifying all our cryptographic algorithms. So this is a flowchart.
So what basically happens during this flowchart? So we have you could like have them classified into three regions, being the system overview, the training and test. System overview is the brief overview of what we are doing. So we generate some text files, encrypt each line, and then from encryption we have our data set generated, and from the data set generated we apply various ML algorithms to it and evaluate those ML algorithms. So now upon doing so, we have reached at a particular point where we find that the random forest classifier is a much better fit for this purpose. So how are we going to train our models? So we start with our data set. It has all the lines of text that you would need. What we'll do is basically just first we'll separate these into line-wise text, then pass it through an encoder. That encoder would have 42 cryptographic algorithms, one of the most prevalent cryptographic algorithms. This encoder would convert these lines of text, of course with the help of a key, into cryptograms. Now once we have our cryptograms, we will pass it through an autoencoder to extract some amount of features from this and get a particular idea about the context. Now with this context we pass into our random forest classifier. This classifier will generate a classification of sort. Alright. Now once we have our classification, we put this classification back to our cryptogram and then decrypt this cryptogram using that particular, let's say it says some XYZ algorithm has been used to encrypt this. Now using XYZ algorithm and that particular key, we decrypt that cryptogram and get some decrypted text. Now two scenarios arise where we have that the classification was correct. Okay, when the classification was correct, go ahead, we'll reward our model, and when the classification was wrong, we'll penalize it. Now what is the metric through which we are deciding to how we are going to penalize or reward this? It's quite simple. We'll use KL divergence. So with the help of KL divergence, now the KL divergence between the decrypted text and possible sensible human or English text would be low if the classification was correct, and thus will reward our model. If the KL divergence comes out to be high, thus means that our classification was incorrect and will penalize my model accordingly, and this whole process just repeats in form of batches and all to update our model. The test is quite simple. We just apply our cipher text, pass it through the autoencoder and random forest classifier and get our classification. So that's about the theoretical aspect of what we are planning to do. Now Soumya will show a brief demonstration of our implementation.
So in the brief demonstration of the implementation, so we have a small code for the classification purpose. Since we need a large amount of data sets, so for the data set we have used the Cryptodome library in order to create and generate the data set. So we have AES algorithm, TES algorithm, RSA algorithm that has been generated, and we have saved all these labeled algorithms in a file and have named this file synthetic cryptographic data.csv. After creation of a large amount of data sample, we try to classify it using our random forest classifier and divided our data set into train and test data set. On the test, with the help of the trained data set, we have trained our model, and This model has given the accuracy of 99.99%. It is implemented on a small scale for the demonstration purposes, and that's all we have.
Yes, so for large scale data, of course, the accuracy would continue to dwindle, but for the small scale, the accuracy, as you have seen, is quite high, and we'll be working on this approach and developing it with further iterations. That's all about it from our side. Thank you.